Hey, hi, hello, welcome. This is our second video of the top 100 liked questions, and yesterday we saw one two pointers easy question, and we have solved that. And today we'll take next question in the two pointers category. Today I can see medium question. Easy question was only one, and we already solved that, and we'll go with medium right now. Our today's question is container with most water. You are given an integer array height of length n. There are n vertical lines drawn such that two endpoints of the ith line are I comma 0 and I comma height I. It can start from 0 height and it can go till any height. Okay, find two lines that together with x-axis from form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay, so we have an array. As I said, we have an array with several numbers. This each numbers represents the height of the wall. Okay, so this wall can act as a side wall of a tank. Okay, if you take this one, um, it is a small wall. It just, we can consider this as a centimeter. Okay, 1 centimeter only. And if you take the second one, it is 8 centimeter, and it is 6 centimeter, like this. Okay, you just go on like this, and we want to find um, which wall can, what are the walls can store large amount of water. Okay, in this case, if you see, this line and this line are same, but we have chosen this line. It's a bit small, but still we chose it because this wall, right, this area is, area or length is low, but comparing to this, correct. So if length is greater than this, then we can store a lot of water here, right? So okay, I'm making a drawing. We can consider this as a zeroth index, first index, second index, third, fourth, fifth, sixth, seven, eight. Okay, now this question comes under the two pointers, right? But how we find it, how we can find this as a two pointer? Because in this case we need to find two walls, right? We need to find two walls. The two walls going to store water in between, and we need to find um, which can store, what are the walls can store much water, right? So this is the first index, p1 going to be here, p2 is here. Okay, now um, yeah, now p1 and p2 is here. Now we need to find what is the distance in between. So we need to find the distance, right? So distance, we need to get a formula. p2 is 8 and p1 is 0. Okay, so here we get 8 as the distance. And how much water we can store in this, how long, what is the height of the water we can store? We can store up to 1 centimeter, because one of the wall is 1 centimeter, and another wall is 7 centimeter, but still we can store only up to 1 centimeter, correct? So that water can don't overfall. So 1 centimeter, right? So multiply to 8 and 8. So maximum water we can store is 8. And now I'm going to move my pointer ahead. Now the trick is that, okay, we need to find which pointer we should move on. So in this case, what is our question? Our question is to find the uh, big wall which can store a lot of water, right? So we need to we need to stick with the bigger wall, right? If it is a smaller wall, then we don't need that. So 0th one is this P1 is points to a smaller wall, so we don't need it, right? It cannot store much water, so we don't need it. So I'm removing it. And going to keep my pointer here, P1. So 1 and 8 as usual. I'm going to put my formula 1 and 7. What is the height? What is the minimum height of the wall? 7. Okay, 7 7 49, right? So what is the minimum wall? What is the minimum height of the wall? P2 is pointing the minimum height, smallest height. So I'm moving my pointer one place backward. So here 7 and 1, 6 is the distance. And now I need to get the minimum height is 3, right? Yeah, I think 3. 18. Yeah, I forgot to update one thing. This is the 49, right? So we need to update the maximum here. So maximum is 49. We should update it. 18 is smaller than 49, so we don't need to update in this case. Now again 18 we don't need to update, right? So 18, this is the smallest one, so I don't need to keep my pointer here. I can move ahead. P2. So here 6 minus 1 is 5, and what is the maximum height we can store? 8. 40. But maximum is 49, so still it is minimum, so we don't need to update it. We can skip it. So in this case, right, both are equal, so we can move any pointer. I'm moving it. Okay, P1. Here 6 minus 2, 4. Here the smallest thing is 6. 24. Still it is low, so ignore it and take it. 3, P1, and 6 minus 3 is 3, and what is the minimum height? 2, right? So take the 2. 6, and next minimum height is this one, and so we can remove and move a pointer one step ahead. Here 6 minus 4, 2, it's up to 5, right? So 10. It's still lower than 49, so we cannot update it. Now I'm just removing the smaller one and updating the I'm moving pointer ahead. So still now it is 6 minus 5 is 1, and then it's going up to, it can fill up to 4. So finally it is 4. It's still lower than 49, so we cannot update it. So 49 is the maximum capacity we can store in this tank, so this will be the answer. Just return 49. Okay, that's it. So in this case, what are the things we needed? We need two pointers, p1 and p2. p1 should point um, p1 should point 0th index and p2 should point last index, which means length of the list. Okay, and now we need to store the maximum capacity. Maximum capacity, initially you just keep it as 0, and now we need a while loop. In this while loop you should check one thing, that p1 should be smaller than p2. If it is, then you can proceed. We need one if condition. In this if condition, before the if condition, okay, what we need to check, we need to take the smallest number, right? So yeah, before the if condition we should check a small one thing. Okay, I'm just erasing it. Okay, before the if condition, I need to know that which is the smallest one. So here 1 is the smallest, so take the small wall minimum of p1 and p2, take it. Okay, now I have the minimum wall. Now if after we found it, then we can make the calculation. This will be our formula. Okay, and maximum capacity maximum capacity comma and our formula. Just write our formula, p2 minus p1. We need the range first of all. After that we need the small wall. Okay, that's it. This is our formula. Once you done, then it will automatically store our maximum value to the maximum cap. After that we should move out pointer ahead, right? If now we need if condition. In this if condition, we need to know which pointer to move, right? So if suppose p1 is smaller than p2, here I'm just referring the index only, but actually we should refer the value. Okay, while coding it will see that properly. Okay, p2, and here if p1 is smaller wall, then then move p1 ahead. Yes. Oh yeah, correct. P1 plus equal to 1, else P2, sorry, not plus, minus, here should minus, and finally return the maximum capacity. Okay, this is the code. Actually, we'll write it on the PyCharm and we'll check that is it working or not, and finally we will verify it on LeetCode. I have coded this problem. We'll look into this one by one. Each line will debug and will find what's happening behind, and we'll see how it is storing the values, and uh, yeah, how it's storing the value and how it moves the pointer by. Okay, this is the example which we got from our question or problem, and this is the answer we are expecting. Yeah, this is the answer we are expecting. Okay, now I'm debugging it. Okay, now if you see p1 and p2, it's going to be initialized. Okay, it's initialized. P1 is 0 and P2 is 8. 8 is the length of the list. Okay, and maximum capacity is 0 right now, and taking a while loop, P1 should be smaller than P2. Okay, this is our condition, otherwise it should be breakout and return the value. That's our case, and we are finding the small value. First place small value is 1, and we are applying the formula which we got from our analysis, and then we take the maximum capacity. Now the maximum capacity is 8, and we have stored it because 0 is smaller than 8, right? So we stored it, and we are moving the pointer ahead. Okay, now we move the pointer. Pointers moving to 8. Now in this case, our smallest wall is 7. So when we take the maximum capacity becomes 49 from 8, because 8 is smaller than 49, so we replace the 8 with 49, and we move the else. We comes to else, and we are moving the pointer to. So same like that, it's going through one by one. Okay, whenever the P1 and P2 meets, then we don't proceed further, we just return the value. Now P2 is 5, but still the value is below 49, so we don't update it. It's 4 now, it's 3. Now P2 is 2. Okay, now yeah, now P1 and P2 both are same, so we don't proceed further, we just return the maximum capacity. Maximum capacity is 49 as expected, so this code works. Okay, so I'm just copying this code to LeetCode, running it. Okay, test cases are passed, we'll submit it. It's running. Okay, it's done, and it's gone through all the test cases and passed. So this is our test case, and this is our problem today's problem, and it's working fine. Now we will find what is the time complexity and space complexity for it. Time complexity is order of n, because we are running into a while loop, and this while loop have a flow. Actually, it runs between the length of the value, length of the height. Okay, so in this case, while is just running between that. If there's no any other boundary, or there is no any other nested loop, there is only one loop, while loop, that's it. So there's no any nested loop, right? So we can consider this as a order of n. It's just going in one flow. Next, space. Okay, next, space. What is the space we are using here? I'm not going to create any list here. uh, I'm just using one maximum capacity as variable, and two pointers, p1 and p2. That's it. I'm not using anything else. I'm using a small ball. So this all are static variables. It's just gonna store only one value. It's not gonna store any other list value or anything. So in this case, it is uh, constant. It's not storing anything else, right? So it's one. So this is our time complexity and space complexity, and we did our code. That's it. Okay, we'll meet you again tomorrow on next problem.